Hello, I'm Bailey. I'm going to be doing the collaborative presentation by myself again. I never heard anything from either one of my partners, so I'm just going to do it solo again. Um, I have Math Practice 5, and I'm going to explain how Math Practice 3 is comparative or similar or different. And also in it, I have a couple examples and a couple links to some videos as to where I found my examples. So I'll go ahead and get started. So the Math Practice 5, it's about using appropriate tools strategically. Students who develop strengths, teachers should make it clear as to why they use the manipulatives, like supporting and helping them problem solving skills as well. Some possible tools that they could use, like rulers, compasses, protractors, calculators, some online algebra sources as well, kind of like the GeoGebra, the one that was mentioned in this class as well. Another couple ones could be like paper and pencil, spreadsheets, and things like that. My example that I have, it's considered to be third grade, and the orange third grade right there is clickable, so you can look at the video that I used as well. There's quite a few examples in that video, but I just chose one of them. But it says using connected blocks, kind of like Legos in a way. I forget what they're called exactly. But it says Sally baked 15 cookies. She put them in 3 cookies. Wow, I did not spell that correctly. She put them in 3 cookies in each bag. So she put 3 in each bag. How many bags of cookies did she have? Or the girl that I used for the example, she knew right away that 3 cookies per bag, 3 times 5 is 15. So she knew that there would be 5 bags, but she still used the manipulatives so she could learn it quicker. So another example that I found is kind of for high school students, but it says analyzing graphs of fractions and solutions using a graphing calculator, which I feel like that could be kind of a higher order of thinking as well. Having the teacher kind of describe how to take care of the calculator and making sure to be respectful of tools that aren't theirs necessarily, just to kind of go over those bases as well. I also found the reasoning and why it's important. Proficient students are familiar with tools that are necessary for their grade level in making decisions about when each tool would be helpful, recognizing the gained insight and limitations. So what I believe that means is kind of a process of elimination. If one tool doesn't work, then maybe another one would. Identifying relevant external mathematical resources such as digital content on the website and use them to solve a problem. So something that I found in the classroom that I observed, the teacher really is very strict about using Dreambox. And once the kids are done with Dreambox, her lesson is to have five lessons completed before they can do Prodigy. And they really enjoy Prodigy, like they do it at home, which is amazing because it's a great tool for them to learn math. I usually just observe math, so I'm not completely sure if there's a reading one as well. But I think that would be a really cool tool for them to have to do at school and at home. When making mathematical models, technology can visualize varying assumptions, detecting possible errors, explore consequences, and compare probability with data. that kind of reminded me of the problem set that we just had recently too. So I think that that was pretty neat, that I got this math practice as well. I think that's really neat. For the SIOP model, I kind of just realized, use technological tools to explore and deepen their understanding of the concept, ability to be a hands-on learner and to solve equations or problems. The example that I had, she had the building blocks, but she also had like hundreds blocks as well, and she had everything like set up in trays. So kind of like food trays at like the mall or whatever. But I did have a higher order question. I also have kind of a definition of what that means as well. Higher order questions are critical thinking questions that require students to infer, apply, predict, connect, evaluate, and judge knowledge in new ways. An example that I found, how would you explain this to someone? So I can, in the classroom, I could tell them, like, how would you explain this to your mom? Or how would you explain this to your grandma or your cousin? Or if you're trying to teach your little brother or your little sister how to do something, how would you show them that this tool could be necessary for them to use in the future? So my reflection, I did mention that it's kind of similar to the problem set that I had as well. And I also mentioned the Prodigy and Dreambox resource as well. I think that since this generation of kids right now has a lot of like digital like background, like kids having cell phones really early is kind of pushing me in a way that screen time is kind of necessary now for kids. So I don't know, I think that would be kind of cool to keep that up. So for comparing the two math practices, I originally had math practice 3, which is creating common math language, using like vocabulary. It's a lot of discussion, it's a lot of debate, like students pitching in on like something else they could try, different examples that they can try as well. So yeah, so then the math practice 5, it's just tools, like tools that could work and tools that maybe couldn't work. And then it also has that opportunity for you to reach out to other students and, have them see what they think, see what they thought worked and what didn't. Again, process of elimination again. So, yeah, I think they're alike in the way that they kind of collaborate as students. If they need any help, they can ask the teachers as well. I think that both of them were very well picked for me, for my group. I think that they're going to be very useful down the line whenever we do become like official teachers. So yeah, I think it was really nice, and I will be sure to change my spelling in my error on my PowerPoint. I apologize for that. So yeah, thanks.